We're now going to continue with our discussion of parameters in Java using the slides labeled the power of parameters. And in the last screencast, we motivated why parameters are essential for abstraction. And in this screencast, we're going to focus on these two topics, which is how to define and invoke methods with parameters in Java, and how to understand parameters in terms of the Java execution model. And then in two additional screencasts involving different sets of slides, we will talk about these other topics here. So our goal is to study an abstraction over a buggle that makes a stair-like pattern where it goes up and over. And here is a method for a new kind of buggle called a stair buggle. And in this method, called buildStair, the body of this method is that the buggle is going to go to the left, then forward some number of steps, in this case 4, then turn right, and then go forward 4 more steps. And of course, the side length here of the stair, in this case, has a side length of 5, which is 1 more than the amount it goes forward. And we would like to abstract over the side length of the stair that it draws. To do that, we are going to modify the definition of our buildStair method to include a formal parameter, like we talked about in the last screencast. This formal parameter has 2 parts. It has a name, which is essentially the name of a hole inside the body of our method. The name in this case is stair size, and anywhere we wish to refer to the formal parameter, we use the name stair size. And the second part is a type, which says the type of value that we expect the hole to be filled with, in this case, an integer. And that's what we do on the definition side. On the invocation side, we have to supply the actual value we want to substitute for the hole. So in this case, we want to substitute, say, the number 5 for the stair size, and then within the body of the method, we're going to subtract 1 from that to indicate how far the buggle should go forward in each case. So now here's a case in which we have the same definition we had before. We call this officially the instance method declaration. Declaration is just another word for definition. And this is an instance method declaration because it's the declaration of a method for instances of the stair buggle class. We have our formal parameter as usual. And we have now 3 different instance method invocations because we're making 3 different stairs. So making the first stair draws this guy here. Making the second stair draws this guy here. And making the third stair draws this pattern here. And we have 3 different actual parameters, 5, 4, and 3, that are used to draw the 3 different stairs. Now we wish to understand what happens in the Java execution model when we do this example. In particular, we're going to focus on the formal parameters and the actual arguments that we pass. So here we have a scenario in which we have taken the example from the previous slide, and we have a single execution frame that is specifying the run method on our stair world, which in object land is known as SW1. That's its identifier, stair world 1. And in every execution frame, the variable this will be associated with the so-called receiver of the method. In this case, in all cases, the receiver is the entity that's to the left of the dot in our method invocation. So when we invoke the run method, it creates a new execution frame. That execution frame has the variable this that contains the stair world instance that run has been invoked on. And then we have so this is the variable section of our execution frame, and now here is the statement section of our execution frame, which says which statements we are going to execute, and we're going to execute them one by one. So the first statement that we execute is the assignment statement, and we know from last time the assignment statement is done in three parts. The first part is allocating a variable here. So this will allocate a variable named stepper in the variable section of our execution frame. That's going to be the first step. The second step is going to be the creation of a new stair buggle in object land. And the third step is going to be stuffing that value into the variable. And when we perform those three steps, we have created a new stair buggle whose identifier in this case is SB1. The variable stepper has been created. That variable now holds as its value SB1. And notice how the expression has been replaced by the value in object land, which is SB1. And this now says that we know in this local context that the name stepper is just a name for the value SB1 in object land. We now wish to go off and execute the instance method invocation stepper.buildStair of 5. So to execute that, we first have to figure out what the receiver is. The receiver is the expression to the left of the dot. And what we find to the left of the dot is the name of a variable. And the rule in the Java execution model for evaluating a variable is simply to look it up in the variable section of our execution frame. So the whole point of having variables in the execution frame is they tell us the answer to the question, what is the value of this variable? So in this case, we see the value of the variable stepper is none other than stair buggle SB1. And so the result of that evaluation is that stepper becomes SB1. We now also have to evaluate the argument to buildStair, but in this case the argument is just a literal. It's pretty obvious that that value is 5. So we now know that we're invoking the instance method buildStair on stair buggle SB1 with the argument 5. And what do we do in the Java execution model when we invoke a method? The answer is that we build a frame. So we are going to build a new frame, and we are going to show that frame as branching off from the method invocation. That frame has a title. The title of that frame indicates the receiver and arguments and the method name. So in this case, we know the title of the frame is this is the frame for buildStair on buggle SB1 with argument 5. As before, we always fill in a variable named this to be the receiver of the method. In this case, the method is being invoked on stair buggle SB1, so this points to stair buggle SB1. What happens when we have parameters is that each parameter is associated with a variable. So since there was a parameter named stair size, we are going to create a variable named stair size in the variable section of our execution frame. And we are going to fill that variable with the value of the actual argument. So since the actual argument in this case was 5, we are going to fill our variable with the value 5. And what this says is that in this particular context, within this execution frame, should we ever come across the variable named stair size, the meaning of that variable will be 5. And so this is the way that Java is taking care of the details of parameter passing. It says that this argument 5 will fill the whole stair size. And this is how the whole filling process is being explained in the Java execution model. So let's go forward and see how that all works. So within the buildStair execution frame, we now want to execute the first statement, which is this dot left. And so the first thing we have to do is to evaluate the receiver, which is the expression to the left of the dot. And to do that, we have to look up the variable named this within this execution frame. And in this execution frame, the variable this is the buggle SB1. So that's how that works there. Now notice that in the other execution frame, this had a different value. But whenever you're evaluating variables, you always evaluate them relative to the execution frame that you're in. So you never look at any other execution frame, and you should never be confused by any other names that are any other execution frame. So in this case, this is the stair buggle SB1, and now we actually invoke the left method on SB1. And in the Java execution model, the invocation of the left method actually creates a frame, but we do not show in our model the details of the execution of that frame. We just assume it's a primitive and that it just happens. So we are just going to turn our stair buggle SB1 to the left, and it turns to the left, so it's now heading north. We can now go to execute the second of our statements. Again, the first thing we need to do within the execution of this instance method, because this statement is an instance method invocation, is we invoke the expression to the left of the dot, which is this. We evaluate the variable this, which we know in this execution frame is stair buggle SB1. And the next thing we have to do is evaluate whatever arguments that this method invocation has. In this case, the argument expression is stair size -1, and to evaluate stair size -1, we need to evaluate stair size. Well, what is stair size in this particular invocation? To determine the answer to that, we simply look in the variable section of our execution frame, and we determine that stair size is the value 5. That is, we are substituting the number 5 into the whole name stair size, so that when we do that evaluation, stair size becomes 5. We now do arithmetic to determine that 5 minus 1 is 4, and now we send our buggle forward 4 steps, which causes it to move forward in our execution land. Sorry, in our object land, we can see that it has moved forward up here. Okay, so now we are going to execute the statement this.write. We execute the receiver this, determine that that is SB1, and now we send our buggle to the right. And finally, we have one more execution of this.forward stair size -1, and we're going to do the same thing we did 2 statements previous, which is that we're going to evaluate the receiver this to SB1, and we are going to evaluate the argument stair size to 5, and 5 minus 1 is 4. So we are going to now make the buggle go forward 4 steps. And so at the end of this whole process, the buggle has drawn a stair of side length 5, and it has moved to a new position. And now we are done with the execution of the method invocation buildStair5. And when you are done with the execution of all statements within the execution frame, the execution frame goes away, and we go off to execute the next statement wherever we were before. So we're now going back to where we were before in our first execution frame, and we are now executing the method invocation stepper.buildStair of 4. So the only difference between this invocation and the previous one is that our argument is 4. So we are invoking a instance method, and when we invoke an instance method in the Java execution model, we create a frame. This is just like the frame we created before. The only difference is that now, because the argument is a 4, let's get this right, the argument is a 4, that means that we now have a stair size variable in our execution frame that is 4 rather than 5. And now we go forward with the execution of each of our elements in the frame. And the only difference now is that stair size is 4, so stair size -1 is 3. So now our buggle has gone forward 3 steps up and 3 steps to the right. And when we're done with that, the execution frame goes away. We now have our third and final invocation of an instance method on buildStair of 3. This, of course, builds another execution frame, the only difference being that we now have a stair size of 3, and that means that every time we come across a stair size variable, it will be 3, and 3 minus 1 is 2. So we will now not show the details, but this will create a stair size of 2. And then we are done with the execution of this frame, and we see that our buggle has now made 3 stairs.